Hi guys, I'm Francesca Dashak. I'm teaching CAD workshop number 2, creating a robotic arm using Fusion 360. So the first thing you have to do is download Fusion 360. If you don't already have it, what you need to do is go to this link provided here, and it will take you to the Fusion website. All you have to do, if you have an account already for Autodesk, then you can just sign in. Otherwise, you have to create an account. And they verify the educational institution that you attend. In this case, it's University of Rochester. And then you can just download it onto your device. So in this workshop, we're going to be creating a robotic arm that consists of 2 arm segments that rotate using stepper motors. Basically, this arm will be used later on in other workshops. You will program it to find the quickest path to a specified point later on. So things you need to take into consideration when creating anything in CAD, you need to take into consideration your requirements and your constraints. So in this case, the requirements are objectives of your design. So we want to have 2 arm segments that are able to rotate using stepper motors. Design constraints are the limitations of the design. So what things will stop us from making whatever we want with this CAD model, right? And on the right, you can see the engineering design process. It's a set of tasks you have to do in order to design something properly. So number 1, you can see we have to define the problem. In this case, the problem is we want to make an arm with 2 arm segments that can be 3D printed and used and controlled with stepper motors. Then you want to do some background research. So we've already done that for you. We've found the stepper motors that are best to use, and we found what size constraints we need for the 3D printer we're using. Then you need to specify your requirements. In this case, we definitely want 2 arm segments. We want it to be able to be 3D printed. It should be powered by these specific stepper motors. Then you'll brainstorm, evaluate, and choose your solution. And this will be based on anything you find out during your research and your requirement phase. Then you develop and prototype a solution, test, and go back depending on what happens during your tests and prototypes. And then eventually you communicate your result. First, we're going to identify the constraints of this design because they're pretty straightforward. Basically, we need to be 3D printing these arm segments. So we can't have like massive arm segments that don't fit in the 3D printing bed, right? Unless you have like a giant 3D printer, which I believe Joe will talk about more in the next workshop, which is the 3D printing workshop. So the stepper motors can't move them around properly. And we also have specific dimensions for these stepper motors, and the arm segments must like fit those dimensions. So we want something that the stepper motor can move easily and something that connects to the stepper motor appropriately. And also, as per usual, we want to keep in mind that we need space for wiring and we need to be able to mount these properly, space for screws and the motor mounts. So to conserve time, we've already developed a solution. This is 2 arm segments that will be rotated by stepper motors. The first segment you can see has 1 stepper motor attached to it. It's the pink one on top. The stepper motor attaches to a motor mount, which connects to the first arm segment, the pink one. There are holes throughout the segment that make it easier to 3D print and lighter to move around. So this basically conserves a lot of energy for our stepper motors. The second segment is the blue one. It includes 2 places for the stepper motors to be mounted, and this will allow it to rotate itself and also the top segment. And then we also have a motor mount on the bottom that's orange, you can see. This will be 3D printed as well. And also we have a stepper motor mount that's orange that's 3D printed on the bottom that you can see. And this will just keep the stepper motor in place and attach it to whatever you want to attach it to. So I'm just going to name some of the parts so that this workshop is a lot more like straightforward and not just me throwing random names around. So the pink segment will be segment 1. The stepper motor that connects segment 1 and segment 2 is the joining stepper motor. Segment 2 is the blue segment. The base stepper motor is the stepper motor on the bottom that connects to segment 2, and it is contained in a motor mount that's orange that will be 3D printed and attached to whatever you want it to be attached to. And another thing to note that we will be using during this workshop is something called GrabCAD. It's a free website that you can sign up for and upload your own designs to. And there are like millions of users who upload their designs for anything they've CADed recently. And you can download these CAD files for free and use them in your own designs. So it's super useful for us in this case because we're using store-bought parts. So to re-CAD this will be really annoying because we'll have to measure everything exactly and like go off of their dimensions, and it's very complicated. But luckily, due to GrabCAD, we could just download the file and then use those measurements, which is very convenient. So there are 3 things you have to download to actually participate in this workshop. You need to download the stepper motor file that will be from GrabCAD. And that's the first link included in this slideshow. So it will take you to this website here. It shows the stepper motor and some like parts that you will need for the stepper motor assembly. You just press download files. You might need to create an account. In this case, I have an account, so I'm just going to log in. Download the files, and it should download in a zip format. You can unzip this, and it'll have a folder containing every single part that you need. The next link should take you to a manufacturing website, Polulu Robotics and Electronics. This is the mounting hub that will be connected to the stepper motor. And what you want to do is go to the Resources tab down here and just download the 3D model right here. So click on that and it should download as a step file. And then the last link will link to A360, which is an online database of all of your files for Fusion 360. Basically is the motor mount that I talked about before. You just want to press download and then go down to step. It'll send you an email when it's done, and you can press download file and it'll download as a step file. And then you're gonna want to open Fusion 360 and you're just gonna want to upload them into a folder. Yeah, let's talk about Fusion 360 for a little bit. So the way that Fusion 360 works is you have projects on the left. These are like folders with all of your files in them. And then on the right is your workspace where you actually design the parts. So in this case, I've just pinned some of my like most used ones, and I made a new folder here. You can just click new project and then name it. I'll call this one workshop 2, and inside, obviously there are no files yet because I haven't done anything yet. If it's not letting you do some stuff, it might be because you're actually in a team account. So if you go up here to your name, you should not be selected as teams you're a member of. You should be in single user storage. Another thing that's possible that you might have an issue with is you might have an issue with your performance. So one quick tip is you can go here to the question mark, support and diagnostics, and then graphics diagnostic. And you can check this box down here that says limit effects to optimize performance. And this will basically turn off some of the like fancy graphics that make your computer slow while you're designing. Now you want to upload all of these files you just downloaded into Fusion. So press upload and select your files from wherever you downloaded them to. I'm going to upload the motor holder first. Next, I'm going to upload the motor connector. And lastly, I'm going to upload the stepper motor. And what I'm going to use to upload this is a .iam file. As you can see, it won't just upload that. You have to also select the parts for the subassembly. And now you can open these files and practice like navigating around in Fusion. So the commands you need to know to be able to navigate. Middle click allows you to pan around in the file. If you press middle click and shift, it'll allow you to rotate the object so you can see all sides of it. Another way you can rotate the object is this navigation cube in the corner. You just click part of it and then move it around and it'll move the part as well. And this part is also really convenient because you can press home and it'll bring you back to your home view no matter what. Even if you zoom out really far and you press home, it'll bring you back. You can also select faces of this cube and it will bring you to that view. So in this case, this is a front view that's rotated 90 degrees to the right. You can rotate it using these little arrows here. And you can select corners of the cube to bring it to isometric views. Now we're not going to be using these files that we just uploaded until we actually assemble this design. So you can close out of them. This is a view of what you just downloaded. So on the left is a motor shaft hub, and on the right is the actual motor that you downloaded. And first we're going to design the first segment, which is the pink segment on top. And we have a few specifications for this. First of all, you need to be able to screw the motor shaft hub into the part, and you have to consider area for wires, nuts, and bolts, basically. And I've already designed this part, so you can use this dimension drawing in order to actually create the part. You have two-dimensional views of the part that you will use to combine to make a three-dimensional view. And we're going to start by CADing this front view. So first we're going to create a sketch, and that's this little tool up here. It's a square with like a drawing inside and a green plus sign. You click that and then you select the view. All sketches are two-dimensional, and you're just going to be basically sketching one side of the part and then extruding it later to make it 3D. So what we're going to do for this part is we're going to sketch this oval with the holes in, and we're only going to extrude the area around the holes so that the holes remain holes. And as you can see in this drawing, we're facing the segment for like front onwards, and it's standing upright. I'm going to select the front plane here. and I'm going to be drawing it facing it from the front. I'm also now going to save my work, and I'm just going to call this segment 1. And make sure you're saving it under the folder that you want to be saving it in, so I'm saving it in Workshop 2. You can check that you saved it by going over here and checking the data panel, and it should appear in your folder that you're in. Another good thing about Fusion you should know is you can zoom out and in on a sketch or in 3 dimensions using your scroll wheel. It's very useful. So I'm going to start by sketching 2 lines, and using these lines, I'm going to show you some constraints. So first, I'm going to attach the base of this line to the origin of this sketch. So you can see the origin here is the circle with 2 dark shaded parts and then 2 light parts. And when you hover over it after you've selected the line tool, it should have a blue box that covers it. And if you click it there, it will be constrained to the origin. And you can snap it vertically, and it will constrain vertically, at least for this purpose, but I'm going to choose to make it a little bit crooked so that I can show you how to make it straight if you mess up. Another thing to note is that if you finish creating a line, it will automatically create a new line, and to get rid of that, you have to press escape. And there is a shortcut for the line tool. You just press L on your keyboard, and it'll automatically make a line, open the line tool, I guess. So I'm going to create another line next to this, and I'm going to escape again. Now to make these 2 lines vertical, I'm going to choose the horizontal/vertical constraint up here, and I'm just going to click the whole line, and it will automatically constrain to vertical. Another thing to know is that if you have your line closer to a horizontal line, so less than 45 degrees from the x-axis, then when you select your horizontal vertical constraint, it will constrain to horizontal. So definitely don't do that. Next, I know that I want the 2 bottoms of these lines to be on the same line, in this case, the x-axis. So I'm going to choose the horizontal vertical constraint again, and I'm going to select these 2 bottom points. Lastly, I know that these 2 lines should be equal, so I'm going to choose the equal constraint up here and then select the 2 lines. So you can tell if your drawing is fully constrained by the color of the lines and shapes. So you can tell that this line here is not constrained because it's still blue. This line is almost fully constrained because it's black, but this tip right here is still blue, which means it's not constrained fully. And the reason that it's not constrained fully is the size. This one is not constrained fully in the distance from the original line. So next I'm going to put this arc up here into my drawing. We know we want it to have a radius of 20, so that's good to know. I'm going to go down to the create tool. I'm going to select arc and then 3-point arc. And this 3-point arc is basically you select 2 points for where you want the arc to connect to, and then you select the extent of the arc. You can choose whatever. And the way that Fusion defines an arc is part of a circle whose center point is here, and that's what you will be constraining. So I know that I want this to be 20 millimeters in radius, so I'm going to put 20 here. And that means that my other sizes are a little bit off. Another thing I know I want to do is make these tangent to the lines. So I'm going to use the tangent tool here. Select the arc and the line, and it will be tangent. Another good way to check if you've fully constrained what you wanted to constrain. For example, I can't see another tangent constraint here. I know that it is tangentially constrained because I've defined the radius and I've defined these lines to be equal, so it has to be tangent. But you can also check by just trying to add another constraint. And if it comes up with this error saying the sketch geometry is over constrained, that means that you already have all the constraints you need. So now I'm going to add another arc onto the bottom. And I'm going to show you another way to make sure that these are tangent. You can choose the horizontal vertical tool again, select this midpoint of the arc, and then one of the endpoints of those lines. So now this oval is almost completely constrained. We just need to define the length. So I'm going to look over here, and we want the length to be 140 millimeters. Now you'll notice that the length is going from the tip of that arc to the bottom of the bottom arc. But if you just select these arcs here, it goes from their midpoints, and that's not what we want. So instead, we're going to put a midpoint of this on this arc, and we're going to put a midpoint on the bottom arc, and then define the distance between them. And there's a shortcut to do this. So you press dimension, and then you press shift, and hold shift while you're hovering over the arc. And this symbol should show up. It's an X on the midpoint, and it shows that it's a midpoint with a little like blue triangle next to it. If you click that, it will put a point there. And then if you press shift and hold over the bottom one, you'll also find one there. And then when you move your mouse outwards, it's defining the distance between them. We want it to be 140, so I'm going to put 140. Another thing is if you don't have millimeters as your units, you can go over here to document settings to the drop-down menu, and then select change active units, and you can change them to whatever you want. Okay, so I've defined the oval. Now I'm going to put in some holes. So I know I want 4 holes in a square formation down here, and I want them to be 3.05 millimeters in diameter. This is the symbol for a diameter, by the way. And radius always has a capital R before the number. And now I'm going to put in my 4 circles. So I'm going to put one here, one here, one here, and one here. And you'll notice they're all different sizes, but we want them to be equal. So what I'm going to do is constrain them all to the same size. What I'm going to do is I'm going to create a constraint chain, is what I like to call it. I don't really know if there's a proper term, but it's basically where you're defining constraints in a specific order that will make things easier for you in the long run. So I'm going to use this as an example. Say I have 5 circles and I want them all to be equal size, right? Well, let's say I define the first one to be 50, and I want these all to be equal to it. One thing I could do is select each circle and then individually set it equal to the first circle. And this means that they will all be equal to 50, which is correct. However, let's say I find out I only need 4 circles and this one's in the wrong place, and I delete this. These are all of a sudden unconstrained. And even if I constrain the first one of these are still not defined, as you can see, because I can change the size of them. And that's because they were constrained and set equal to the first one and not each other. So what I'm going to do is create a chain of like constraint. Let's say the first one is 50 again. What I'm going to do is set the second one equal to the first one, the third one equal to the second one, the fourth one equal to the third one, and the fifth one equal to the fourth one. And then if I have to delete this circle, all I need to do is redefine this length of the diameter, and these will all be the same equal size. So that's what I'll be doing here. First, I'm going to define this as 3.05 millimeters in diameter, and then I'm going to set these equal to each other. So second equal to first, third equal to second, fourth equal to third. Next, I know I want them to be in a square formation. That means the top 2 are going to be horizontally constrained, and the side 2 will be vertically constrained. So I'm just going to add these constraints myself. And just a friendly reminder, when you're selecting circles to be constrained to each other, you select the midpoints, and it will select the whole circle. And now they should be constrained in all of these dimensions. Finally, I'm going to set the distance between them to be uniform. So I want the distance to be 9. And since they're in a square, the side distance will also be 9. So now we have a square of circles, but we don't know where we want them to be. So we see that we want the top one to be 24.5 millimeters from the bottom of the arc. So I will define that by selecting one of these top circles midpoints and then the bottom midpoint of the arc. We want 24.5. And then finally, we want these to be centered in this oval. And so I'm going to add another dimension from one of these top circles and the midpoint of this arc, which is also coincidentally the midpoint of the oval. And I'm going to set it equal to 9/2. And the reason for that is that the distance between these 2 bottom ones is 9, and we want it to be that over 2 basically. And a good thing you can do is select an already existing dimension and then do math with it. So I'm going to do the 4th dimension divided by 2 by just clicking on that dimension. And this is good because if I change this to 10, it will automatically change to 5. I'm going to keep it as 9 though, because that's the value we want. Next, we want a pattern of 14 holes over here, as you can see. and we want a diameter of 9. So now we're gonna make a pattern. Go to create drop down, and we're gonna create another circle. I'm just gonna put it up here randomly, and I'm gonna create a second circle. I'm gonna set the second circle equal to the first circle, and I'm gonna define the diameter of the first circle as 9 millimeters. We want them to be horizontally constrained to each other, so I'm just gonna constrain that. And then I'm gonna set the distance between them. I believe 15 millimeters, okay? That's 15 millimeters. Then I'm gonna center them again using the same method we had before, the center point and then one of the triangle, one of the circles. I'm gonna say it's a 15 over 2, and now it's centered. I'm gonna make a pattern now, so go to the create drop down and select rectangular pattern. You're gonna select the objects you're gonna pattern, so press shift to select the 2 circles, and you only need to select the outer rim of the circle because the center point will automatically be created for all of the circles. You don't need to choose a direction. This is only really if you're gonna copy it in a direction that isn't directly upwards or directly sideways, but we're copying it directly downwards. And you can choose the arrow of the direction you want. So I'm gonna choose this arrow and pull it downwards. As you can see, it automatically does 3, but we want more than that. And while you're dragging this arrow, you can see on the right in the rectangular pattern box which value is changing for distance. And that's the one that you want to change the quantity of. So I'm going to change it to 7. 7 times 2 is 14. And let's see how far down we want it to go. We want it to go 90 down. And there are actually 2 different methods of spacing holes in a pattern. This first one is extent. And this is basically you're choosing how far, like over how much distance this pattern will span. And now we've created a pattern of 14 circles, and we will now constrain them finally fully. The only thing we have left to do is define how high up these circles go, and this is entirely up to you. It's not actually constrained. Oops, it's not actually constrained on this drawing, so I'm just going to choose 10. Seems like a pretty standard value, so 10. There we go. And now you have the satisfying result of seeing that your sketch is fully constrained. Everything is black, nothing is blue. You can press finish sketch over here, and the internal part of this sketch should be light blue, and that indicates that all of these lines are connecting, so there's no open area where this shape isn't fully constrained. Next, we're going to extrude the part of this that we want to exist. So you can either press this button over here, over the create dropdown called extrude, or you can press E on your keyboard for extrude and select the outer area. I'm going to move it a little in 3D, and you can drag this arrow outwards however far you want it to extrude. We want it to extrude 5 millimeters, so you can either drag it out to 5 millimeters, or if it's not snapping, you can go over here and manually change it to 5 millimeters. And you've created segment 1. Finally, if you want it to look pretty, you can change the appearance by double-clicking and then right-clicking. Select Appearance, and then over here you can see what material it automatically sets it to, so steel satin. You can right-click on this and press Edit, and then choose whatever color you want. It even has color libraries that you can choose from. So it's entirely up to you. I chose this color, and now we're going to go into segment 2. But before you close, make sure to save over here using the save button. Looks like a tiny floppy disk, and press OK. It should save as a new version over here, and you can close out. So now that you've finished segment 1, you've learned a few of the basic skills needed to make anything in Fusion 360. You've learned creating a sketch, constraints, dimensioning, and extrusions. Next, we're going to CAD the second segment, and you're going to learn a few more skills needed to make a lot of parts in Fusion. We have some more design specifications for this. We need an area that permits it to be screwed into a base motor. And this one will be also screwed into the shaft motor hub, the 4 circular holes we saw in a square formation before. We need area that allows the second motor to be mounted. That will be the motor directly connected to the part. And we also need area for wires, nuts, and bolts as usual. So we've also designed this one, and all the dimensions are in the drawing. And we're going to try and go through this one a bit quicker than the last one. So I'm going to close that. Select the front face, and I'm going to save it as segment 2. Okay, now I'm going to create 2 lines and constrain them equal and horizontal. I'm going to make an arc between them. And now I'm going to teach you the mirror tool. So first I'm going to dimension these. I know I want the arc to be 20 millimeters in radius again. So this is maybe a little too, yep, okay. What I'm going to do is create a construction line at the bottom of this shape that we will use as a mirror line. So to go into construction mode, you go over here to your sketch palette and you select construction, and this should be highlighted blue. And now you're in construction mode. So I'll create a line from this bottom point to the other bottom point. The line should appear dotted, which this one does. And basically this means that if you were to extrude this part, the dotted line wouldn't count as a real line. So this sketch is technically open and not a closed shape. It's really just for you to use for constraints and temporary dimensions while you're creating the part in a sketch. So you go to the create dropdown and you select mirror. I'm gonna press shift and select everything I want to mirror. So I want to mirror this top arc and these 2 side lines. Then I'm gonna select the mirror line over here, and that's gonna be my dotted line. And then I'm gonna press OK. And it creates a shape exactly as we want it to. Now we want the length to be 180 millimeters. So I'm gonna press shift, hover over the arc to select the midpoints again. And 180. And the good thing about a mirror is you can still edit the shape afterwards. It doesn't like automatically constrain everything, so you can't do anything anymore. Next, we're gonna create these 4 circular holes and a square formation down here. But this time we're gonna use construction lines to do this. So I'm still in construction mode over here, so that's good. I'm gonna select the rectangle tool, and I'm gonna create a square down here. Now, right now it's a rectangle because the sides are not equal, but we can fix that with a simple constraint. These 2 sides should be equal to each other. We're gonna use a similar concept of pressing shift and hovering over the midpoint. So I'm gonna select the horizontal vertical, shift and hover over this line, and then I'm gonna select the center point of this arc. And now that square will be in the center of this oval no matter what. Next, I know I want the side lengths to be 9. I only have to dimension one of these lengths because it's equal to each other. And I'm gonna check how far up I want it to be. I want it to be 15.5 millimeters from the bottom of this arc. And now I'm going to create circles on each corner of this square. So I'm going to go out of construction mode by clicking the construction tool, and I'm going to make 4 circles. I'm just going to make them in random points right now. I'm going to do chain equal constraints. So second equal to first, third equal to second, fourth equal to third. And now I'm going to use the coincident tool to constrain these circles to the corners of the squares. So I'm going to select the coincident tool. I'm going to select the midpoint of the circle and then the corner of the square. And that circle will now be constrained to the corner of the square. I'm going to do each of these circles for one corner of the square. And I'm just going to dimension this first circle here, 3.05 millimeters in diameter. Okay, the next step is to make these 12 holes here. These will also be patterned, but we're going to use a different method of defining how far they extend. So I'm going to create 2 circles first, like last time, set them equal to each other, dimension the first one to be 9. And I'm going to horizontally, and I'm going to use another construction line to constrain these holes. So I'm going to go over to construction mode again and create a line in between these 2 circles. Press escape. I'm going to define the line to be 15 because we want them to be 15 apart. And then I'm going to use the horizontal / vertical constraint again, pressing shift to select the midpoint of this construction line. And I'm going to select the center of the arc. Now these holes should be in the center of this oval. I'm going to go out of construction mode, I'm going to go to the Create dropdown and select Rectangular Pattern again. And for the objects, I'm going to press Shift and select these two circles, outer rims. Next, I'm going to change the distance type. So as you can see in this drawing, we don't actually have a distance that we want this to span. We just have a distance in between the holes that we want. So I'm going to select spacing. And I'm going to choose the direction again. We want it to be that far up. And I'm going to change the distance to 15 millimeters. This will make the distance in between the rows 15 millimeters. Finally, I'm going to change the quantity to 6, so there are 12 holes, and we are done. Lastly, we need to define the distance between these holes and these bottom holes. Once again, I'm just going to do 10 millimeters. It's not defined in the drawing. Next, we have these 3 oddly spaced holes up here. So first, I'm going to create one big hole that will be vertically constrained to the center point of that arc. And we want the diameter of that hole to be 12 millimeters. Next, there are 2 holes over here, each 4.2 millimeters in diameter. So I'm going to place them randomly, set the bottom one equal to the top one, and then dimension the top one to be 4.2 millimeters. You can also press D on your keyboard for a shortcut to dimension things. We know we want them to be vertically constrained, so we're going to do that. And we know that we want this center circle here to be 17.5 millimeters from the bottom circle. So I will define that, 17.5. Lastly, we know that we want it to be 35 millimeters apart for these 2 holes. So I'm going to set that equal to 35. Lastly, we need to set the distance between these 2 as 8 millimeters. Select the center point, and 8 millimeters, that's 9, 8 millimeters. And we want the distance from this top hole to the tip of the arc to be 20 millimeters. So I'm going to do that. And now everything is constrained. That's everything we have to do. So I'm going to press Finish Sketch, E for Extrude, select the outside, and extrude it 5 millimeters. Finally, I'm going to change the color of this, and I chose blue. Save your part, and you're done. So now that you've finished segment 2, you've learned a few more of the skills you need to be able to CAD stuff in Fusion 360. Now we're going to create a working assembly of all of these parts. So this is a feature of Fusion that's really useful. It basically allows you to see how your things will fit together. So first, we're going to open a new tab. I'm already in a new tab, and you have to save it before you make it into an assembly. So I'm going to call this an assembly of arm, and make sure you're saving to the right location. Now, the first thing we have to do is insert the base part. So I know that we want to put a motor holder in first. So I'm going to right click on this motor holder. By the way, it's really useful to have your data panel open now. So right click on the motor holder and insert into current design. And you can choose to rotate this to the proper formation. So we know, if I go back, we know that we want the base to be the open part facing downwards, and we want these 2 flat parts to be on the front. So you can select these circles here and rotate it to however you want it to be. Always make sure that your rotation is a multiple of 90, so that you're actually rotating it to be perpendicular to however it was put in. I'll press OK. And you can see that you put in your first part. Next, you need to ground this part. So this is the base of the whole assembly, and you don't want this part to be moving at all. So double click it, right click, and then press ground. And this basically means that now whenever you pull, you can't pull this part at all, because it is your base part. Now we're going to insert the stepper motor. So right click the stepper motor and insert into current design. This one also came in a bit crooked, so I'm going to rotate it facing this way. Make sure it's a multiple of 90, so negative 180 is, and then I'm going to rotate it upwards 90 degrees. You can also change these manually over here. And lastly, this center dot is how you will move it, like translate it around. So you just want to move it outside for easy access and then press OK. You can also change this if you mess it up the first time and move it later by clicking modify and then selecting move You select the parts. Well, first you have to check components instead of parts. And you select all of these components, and then you can move them around wherever you want to move them. Another thing you might notice about this motor is if you move the motor body, the shaft stays in the same place. By the way, you can press Control Z to undo what you just did. So what we're going to do is rigid group these two bodies. So you double click, then right click and select rigid group. And now what they are is individual components. So if you select it, it will deselect, and then you can select the individual parts. Make sure that both are highlighted blue, and then select OK. And now if you move it around, it will move the whole thing, which is good. So now I'm going to join these two segments. So I'm going to go up here to assemble and press the joint. It looks like two hinges. And I'm going to select parts to join. So first I'm going to select one of these holes on the motor. And if you hover around the hole, you can select the rim of the hole. That's exactly what I'm going to select. And then I'm going to select this rim right here because we want to connect them flat so that they are flush to each other. And if you select motion, make sure it's rigid and it should be okay. Now you can't move this motor anymore because it's rigidly connected to the base. Next, we're going to insert the mounting hub. So I'm going to select and right click and then insert into current design. And it came in exactly how I want it to, so that's good. And I'm going to press OK. And what we're going to do is join this motor hub to the motor shaft using a joint. So I'm going to select join again. I'm going to select the inside of this hole. So you might need to zoom in and move around a little. You want to select this inside section. And then I'm going to select this outside joint here. And as you can see, it pushed in a little bit far, so I can move it out manually to however far I want it to go. In that case, I want it to be here. Next, we don't want this to be rigid because we want this motor hub to be able to move around. In real life, obviously, the motor axle is the thing that's actually rotating, but for our purposes, we can allow this to be the thing that rotates. So we're going to choose a revolute joint, make sure it's around the right axis. In this case, it should be the Z axis, and then press OK. And now you can check if this is actually working by selecting the motor hub and moving it around, and it should be able to rotate. Very cool. Next, I'm going to insert segment 2. So I'm going to click it, right click, and insert into current design. And I'm just going to move it over for convenience. And what I want to do is connect these 4 holes to these 4 holes on the motor hub. So I'm going to rotate so I can view the back of this part. And I'm going to select one of these holes on the rim. And what you're going to be selecting will highlight black. So I know that I want to select this rim, so I'm going to click there. And make sure you remember which hole you selected so that you know where you're actually snapping it to. In this case, I want it to snap to this hole, and it should center constrain to that hole. But we don't want this to be a rotational joint, so I'm going to change it to rigid. And this means that when we move this arm segment, what's really rotating is the motor hub, which is correct. And now you'll be able to rotate the arm properly. Also, if you want to set it to specific degrees, you can select this rotational joint here, double click. Oh, you can select this joint here, double click, and then change it to 0 or whatever you want it to. Okay, next I'm going to insert another motor. So I'm going to go over here and insert into current design and move it outwards. Once again, you'll have to group it. So rigid group, capture position, and select the axle as well and press OK. Now we know that we want the motor to connect in the back to this segment. So I'm going to choose joint, and then I'm going to zoom in and select the rim of this hole. Now I know that I want that hole to be on the bottom, so I'm going to zoom in and select the rim of the bottom hole. And as you can see, for some reason, it decided to mesh inside the material. So I'm going to press flip down here, and then I'm going to rotate it to the appropriate area that I want it to be, so 90 degrees. And it should show like a shaft area that will stick through. So press OK and make sure the shaft sticks through, which is correct. Now we want to insert another motor hub. So I'm going to put it over here. and I'm going to join it to the motor shaft using a rotational joint. Motion, revolute, okay. Finally, we want to insert our last segment, which is segment 1. So right click, insert into current design, and I'm going to move it out of the way for convenience. I want to connect it to the motor hub, so I'm going to go to the back view and select joint. Click the rim of one of the holes, and then make sure you know which hole you clicked so you can choose the corresponding joint. Now you don't want this to be revolute, so select rigid and make sure all the holes line up, which they do, and then press OK. And now you should be able to move this arm using your mouse. And you've created a successful working assembly of your arm. Make sure to save, and then you can exit. So in case you didn't get what I did, there's a guide for how to assemble it. And you can always rewind this video and watch it in slow motion or however you want to watch it. So thanks for watching. This was CAD workshop number 2, teaching you how to actually create stuff in Fusion 360 and create a working assembly. If you have any questions, you can email me. It's fdaszak, FDASZAK, @u.rochester.edu.